So hello everyone and welcome to this next session. So as before we begin, just a quick recap as to what we'll be doing in the past. In the previous lecture we talked about NumPy, and in this lecture we will start with Matplotlib. So before I start, does anyone have any questions about what we did so far? Anyway, it's almost 4 p.m. so I will get started. So this is where we were last time, right? So we were just looking at some types of NumPy arrays, and we saw about some of the functions related to arrays and some of the usual functions that we deal with when we talk about NumPy arrays and arrays in general. That is multiplication of arrays, the matrix multiplication, and the element by element multiplication. So now that we've talked about this, before we begin the actual data science part, let's talk a little about plotting, because plotting is quite important even in general terms when we talk about data visualization, because when you create data, it's important that you also be able to visualize it. So as before, let me just import NumPy. Just a little request to everyone to please be on mute. Somebody is not on mute. If you could please be on mute. But anyway, so to get started, let me first create two NumPy arrays. So let me just give it an X array, or I'll just call it X. And let me just put an A range of around 20. Okay. So this is pretty simple. So we have an element, an X array with around 20 elements, right? So now let's create a Y array, which is, let's say, the exponent of this, right? So we say np e and x. So this is what I get. So basically, I'm taking the exponent of this particular, of each element of the X array. So now the first thing you might want to do is, if you want to visualize it, that is, you want to plot Y with respect to X, how would you do so, right? Now, for that, first we have to now import what is called Matplotlib, right? So again, this is a convention that you will see in most data science projects. We will usually import pyplot package from Matplotlib, right? So Matplotlib is the entire package with several plotting packages, out of which pyplot is one of them, and we will import this as PLT, right? As before, this is just a convention. You'll see this in most data science projects. You don't have to stick to it, but this is what you usually see. So if you're wondering what it is, there's nothing complicated. We are just importing pyplot package from Matplotlib as package PLT, right? So let me just execute it, and we should now have plot PLT. So now within PLT, there are several methods. As before, I'll just type the tab and you will see these are all the ones. Okay. Now plotting in Matplotlib is a very, very, very comprehensive package. It's almost impossible for anyone to actually know every command. So I would suggest go ahead and read on the documentation of Matplotlib. Right? It's got a lot of documentation, including several tutorials and even several sample cases, depending on what kind of plots you want to generate. So I'll just talk about a few basic points. So PLT has the most commonly used method called plot. Right? Now, plt.plot will take usually pairs of arguments. Right? What that means is it takes an x-axis and it takes a y-axis. Right? This is quite common. You'll see it even if you come from a MATLAB, from let's say a MATLAB or Simulink kind of background. This would also seem similar to what you would have done there. So if I do this, this is what I get. This is my exponential function. All right, and this tells you here that this is an object of Matplotlib of lines 2D, which means it's a two-dimensional line plot, right? So now that I've been talking for a while, again, I'll take a little pause and I'll say, does anyone have any questions here? No questions at all? Okay, so now I'll just continue for now. The advantage of Matplotlib is that you can actually plot several waveforms on a single plot such as this, right? So for example, let me say that I want to create another plot Z, right? And this will be another function. Let's say, for example, I say NP power. And if you look at the NP power, is basically just taking the power of a particular number, right? That's all. So what I will say is, let's say I say 2 comma x, and let's see what z is. So z is another number where I have taken each element of x. I've taken 2 raised to the power of this, right? So basically 2 raised to the power of 0, 2 raised to the power of 1, 2 raised to the power of 2, 2 raised to the power of 3, all the way up to 2 raised to the power of 90. So now the question is, supposing I want to plot z along with y. The question is, even that is possible. It's important to understand in this plot function, you can combine pairs of plots. So you can combine an x coordinate, a y coordinate, another x coordinate, another y coordinate, and so on. So for example, I can do x comma y, x comma z. And this will now give me 2 of these functions. Of course, the reason why it is such is you have one is almost 0 and the other is almost high is because of the magnitude of it, right? So for example, just to make it a little easier, let me say p is equal to mp dot pow and say 3 comma x. Oh, sorry, power. It's not power, power. And let me plot these two together. X comma z, x comma p. Oh, sorry, x comma p, not z comma p, x comma p. And yes, again, you see a difference, but it's one of the main reasons I think it's let me plot y, and it's the same thing. So here you can see you can actually see the 2 exponents together, correct? So here I'll pause again for a minute and I'll ask the question, does anyone have any doubt?
Yeah, here both the the x-axis is common for both of them. So what happens when it changes?
Sure. So let's try that. So like for example, let me create another x-axis. Let's say x1 is equal to np dot a range. Let's put 25. Okay. So x1 now has 25 elements. X has 20 elements. Okay. And this is just an example, but they can be totally different. Now, the only thing that is important to understand is that the two coordinates have to be compatible. All right. So which means the length of x and the length of y has to be compatible, and the length of x in the second one and the length of y have to be compatible. So think of it as pairs of plots, pairs of waveforms. So let's plot this. So let me create another one. Let's call this y1, and let's say np dot pow, let's say 2, or rather I think it's exp of x1 is y1, right? So now let me now try to plot the y of the with respect to x. That is, let's plot this one and let's plot the new plot and let's compare these two, right? So what that means is plt dot plot x comma y and then x1 comma y1, and this also works. Now the only problem here is you might think that it's actually not right because you only have one of them, but the reason is that I now have a huge power here. So one way to actually sort that out is I'll just create a simpler plot. Let's say, for example, let me call a1 is equal to np dot let's call this sine x1, and let's say a is equal to np dot sine x, right? So now let's try to plot these two together. So let's say x of a and x1 of a1, right? Now you might again think that this is wrong, all right? But really speaking, it's not wrong. I'll tell you why. Let me multiply this first one by 2. And now you see the two plots are there. What has actually happened is this will plot both of them and it will take the x range equivalent to the longer plot. That's it. It will adjust the x range accordingly. So does this solve your doubt?
Yeah, thank you.
Now, however, there's one thing that you need to understand is if you make, for example, let me just do plt.plot. I can copy this. And let me do a slice, right? What I'm saying is I want to decrease this by 1. And now you get an error. What am I trying to do? Let me say I'm taking x1. I have x1 and a1, right? So these two are now compatible. That means if I say a1 dot size, this is 25. But if I do a slice, what that means is I am now decreasing by 1. Right? You see the first element is gone. That's what it is doing. You remember that is what the slice does. The slice means start to stop with step. Step is 1 because we haven't mentioned here. And since we haven't put the stop either, the stop is the end of the array. Now these two are not compatible. So for example, if I copy this and I check the size, this is 24. So my x1 is 25 and my a1 1 colon is 24, which means I now have an incompatible x and y coordinate. And the error is this: x and y must have the same dimensions, but they have different shapes. All right. So you can use even different types of plots. You can have longer plots, shorter plots. Only thing, make sure that the pair of plots have to have the same dimension. Okay. I mean, does anyone have any other doubt?
The delta in the x-axis, will you show how to change that in the next coming up thing? Like now it's 0, 5, 10. Can you control
Okay.
that?
Oh, okay. You mean the X, you mean this limb. Okay. So the first thing is, let me go down. The first thing is, for example, let me just plot this again. It's just more convenient rather than scrolling up and down. So this is what it is, right? So let's look at some other things. Like for example, the question was, can we improve the visuals a little? And yes, you can. So for example, the first thing is, what if you want something which is slightly bigger? Okay. For that, the first thing is you use something called the figure method. So plt.figure does two things. It creates a new plot object. All right. So this object that you see is a figure, is a pyplot figure. So when I say plt figure, I am creating a new plot object. And until the next figure, every plot will come within it, right? So I'll talk about this a little more. But what's important is within this, we can specify some commands. Like for example, you can specify things like DPI, how much resolution you want. You can specify colors. You can specify whether you want a clear plot or you want something with a background. Most importantly, you can specify something called figure size, right? So for example, you can say figure size, and this has to be a 2 because we are specifying the length and the width. So for example, I can say something like 10, 12, right? And now I have a bigger plot, right? So actually this is not very nice. Let's do the other way, 12, 10, because it's length into width, right? So now we have stretched out the space. So this is how you would increase the size of the plot. The next thing you would want to do is you would want to give it a title. So for example, you would say plt.title, and let's give it a plot. So let's say sine waves, right? And you see, now I have a title. Along with this, you can also give it something which is called as, you can give it an X label and a Y label. So for example, I can say X label time, and this is what appears. And you can say Y label, and I don't know what you can call it, maybe amperes, right? And this is what appears. Now, there are other things you can also do. For example, you can also say things like, you give it a grid. So now you have a grid. For example, if you want to find out what are the zero crossings and things like that, this grid is sometimes quite useful. And at the same time, there is also something else that you can do. For example, we have a blue line and we have an orange line. But now in this case, we know, because we've done this multiplication, that the blue line is the first curve and the orange line is the second one. But if you're plotting any two random values, you may not know this. So for that, you have what is called as a legend, right? Now, in the case of a legend, what I would recommend is, like I said, let's split these plots up. So let's plot this one here, and let's plot the second one in the next one. So it's important to understand that once you specify figure, every plot command will generate waveforms within this plot window, right? So if I just click this, you still get the same plot. So I'll just stop for a minute and ask, does anyone have any doubts about what I talked about?
Yeah, I wanted to know in x-axis, if you scroll down to the x-axis, yeah, is that interval, how do you change that interval? Suppose I want only 0, 10, 20. So how do I change that?
You have what is called as xticks, plt.xticks. So now, if you look at the help of this, this tells you what are the ticks you want to give. All right. So for example, okay, tell me, what do you want? 0?
I don't want 5. I want only like 0, 10, and 20. That's it.
That's it. So when you say ticks, these are ticks. These numbers are ticks, and these markers on the X label are called ticks. So if you say X ticks and you specify the numbers you want in a list, it will give you only those numbers on the X axis.
Is there any way to, is there a generalized expression? Let's say I have like 1,000 elements.
You
And
can specify anything, like for example here you can specify np.arange, let's say 2 to 10, 0.5. You get something like this, whatever you want. You can even specify something bigger, it just won't appear. So like for example, let's say I spend something like 50. Okay. So here it will just say, since you specified X ticks, it will appear on your X label. So whatever you specify will appear.
okay, got it. Thanks.
For if you want like further thing, another thing which you can do is what is called xlim. Xlim means you are specifying your ticks, but at the same time you also want to specify a limit. So for example, let's say I want only 2 to 70. Then I get a zoomed in waveform with only 2 and 70. Of course, you can specify what you want. So for example, let's say I want to make this 2,5. So here it will say 2, 7, 12, 70. So basically I'm giving it a step of 5 starting at 2, and I'm restricting my plot to an X range of 2 to 70.
Okay, thank you very much.
Okay. Any other doubts? Okay, so I'll carry on to the next one, and that is how we can generate a legend, right? So a legend means we need to first give them a label. So for example, let's say this is our first label, right? Now this could be something you know. For example, it's a function that you're generating. It could be temperature, pressure, or it could be current, voltage, whatever. So you know what that is. So you can give it a name. So let's say we call this big sine, right? And let's give this another name, which is small sine. All right. Now, just doing this is not enough. Now I have labeled my plots, but for this to come, I must say plt.legend. And now you see the legend appears, and this will say which plot is what. So for example, the first plot is big sine. That is the blue plot, and it is saying that this blue plot is called big sine. The orange plot is called small sine. So you can give any name you want, right? Any name, any string will do. Okay. So any questions here?
Hello?
Hello, yeah.
Yeah, so the legends are appearing one below the other. So what if we want to arrange it in a horizontal way? So how can we do that?
Sure. So all you have to do is let's look at the documentation. So for example, here you see there are several of them, right? So you can say one is you can decide where to plot it, right? So you can actually say where to put it. The other is, let me see if there is sequence of labels, locate, upper. So here, for example, the location will tell you where they are. Usually Matplotlib, if you don't specify anything, it will decide the best possible place, right? But you can choose what you want. So you can say upper left, upper right, lower left, lower right, right? Now, let's look at what you wanted. That is, can we move it next to each other? Font size, null points, scatter points, marker scale. Okay, so obviously, probably it's not there. In that case, all we have to do is go to Google. So Matplotlib, arrange legends next to each other. So let's click this. So usually always best to Google it and you will get something. So for example, this is what he said. Used to use two legends, frame on is equal to false. So the best thing in that case is just Google it.
One more thing,
Yeah.
the step size of the sine wave is means very high. So how to decrease the step size so that the sine wave can be observed very smooth?
Okay. No, that is just because that's how we've done. So let's say we say time. Okay, let's call it a time array. And let's say something NP a range. Let's plot how much? Let's plot 2 cycles, right? So 0 to 0.04, right? Because every cycle is, let's say one cycle is 50 hertz, which has 20 milliseconds. So let's say 40 hertz, 40 milliseconds. And let us plot it with the resolution of, let's say, 100 microseconds, right? So this is our time array. Okay, this is what we get. It's a big array. Now that we have this, let us now create x is equal to np sine of, right? Now we're using 50 hertz, right? So 2 into np dot pi into 50 into time array, right? So what I'm trying to do is I am trying to say 2 pi ft, right? That is sine wave. So let's see what this is, and this is what we get. Now, actually, let me just comment this out because it's just unnecessary scrolling. So now let me plot it. Plt dot plot time array comma x, and we get the sine wave. So to get a smooth sine wave, you need to change the resolution of your x-axis. So the x-axis you can change by using np.arange. You have to specify a start, specify a stop, and to specify an increment. Now, if you don't specify the increment, it will take 1. But if you want to specify a small increment, you will get more resolution. Does this answer your question?
Sure. Thank you.
Yeah.
Yeah.
Any other doubt?
Will you put up this notebook in GitHub later?
Yes, of course. I never thought about it. Yeah, I can save it and put it up on GitHub. Yeah.
Thank you.
Okay, sure. Any other doubt about what we need to do? I can just show one other plot which we will encounter in data science very soon. So that is, let's say, what is called as a bar plot. So for example, let's say, for example, we have X labels. Let's say we have, let's give it some integers. Let's say, for example, we have 2019. I'm saying these are actual indices because rather they're, what I'm trying to do is, let's say we want to plot the sales of a particular shop over the year. So let's say 20 and let's say 21 and let's say that's enough. Okay. And Y is something similar. So let's say, for example, we have, let's say 100, 212, and let's say, okay, I'm almost out of time, so I will wind up soon. 152, let's say. So what if I want to plot a bar chart with this on the x-axis and this on the y-axis, right? And in data science, it's very normal to have something like this. Now, there are various ways to do it. This is, Matplotlib is not the only one. You can use Seaborn, you can use several others, but I'm just going to use Matplotlib just to give you some basic functionality. But we use what is called as a bar plot, right? For bar plot, all you have to do is just say x comma y, right? And this gives you a bar plot. So all you have to do is say, first is what is on the x-axis and what is the height of each bar. So these two, of course, have to be the same length. And then it will give you a bar plot by plotting the x-axis on what different values of the x-axis separately as separate bars and give them a height. So this is something you will see, and we will use this when we go to pandas and data frames and actual data analysis. So any question here? Okay, so if there are no questions, then I think we can pretty much wind up because we are almost out of time in any case. So just before we wind up, in the next lecture, I'll just get started with basic pandas. So in terms of pandas, what we will be using pandas is for actual data analysis. So initially we'll be just creating some data frames on our own and just doing basic manipulations. In the lecture after this, that is after, let's say, day after, that is when we will actually start with data frames from Kaggle. So as I said before, if you haven't created your account on Kaggle, please do so. So you just have to go, it's a free account. So I'll just show you. And you can just go to Kaggle. And here you can sort of register and you get several data sets, right? So for example, if you just browse through data sets, you will see that there are several data sets, right? So you can just go through any of them. For example, you can just look at a lot of it is with coronavirus now, but for example, you can look at something like, hotel booking department. So the way to look at it is once you go, you can just look at the hotel booking department and it will give you the data set with a description of the data set. So for example, it will tell you what is the actual data set, what is it about, and it will give you a sample of it. So for example, what are the data elements in this data set, right? So you could now download this data set by clicking on this button, right? So you can just click on download. It'll download the data set. Usually you'll get it as a zip file. You extract the zip file and you'll get a .csv file or a comma separated value file. So we will start talking about this in probably 2 lectures from now, where we will start downloading some data sets and playing around with them. So I would suggest in the meantime, create your account and just check out some data sets. All right. So this is a good way to just get started before we actually start some analysis of them. So once more, just before I wind up this lecture, just anyone has any doubts about what we talked about?
Yeah, does Matplotlib only work for NumPy arrays or anything?
Oh, anything. It just has to be, again, like a collection. Most importantly, it's important to understand is, I think you cannot plot dictionaries together. So it'll have to be an ordered set, but it can even be a list. So like, for example, let's go try it out. So like, let's say we say X is list range 20. So we can just say plt.plot X and it gives you the same thing. So I don't want you, if you want, you'll actually have to write a function which will return another array. So like, for example, you can say map lambda x into x comma x. Actually, this is, let me call this something else, ax. Oh, because it's a list, it has to be a list. So I'll just cast it as a list. And we get a multiplied list. So it can work with anything as long as they are compatible. That's most important. They have to be compatible.
All right, thank you.
Is there any option to save as a JPG, same like MATLAB?
You can. So for example, you just have to go to plt.savefig, and here just check out the documentation. So you can save it in different forms. Like for example, you can save out a file name. You can look at what you get. So it will save it. You can do that.
Okay, thank you.
Any other last doubt?
Hello, sir.
Yeah, go ahead.
Sir, I had a confusion that when to use triple and when to use square brackets. I got confusion in that.
It's like basically there is no real int functions. Like for example, I think you were talking about this fixed size, right? So what you should do is just look at the documentation, right? So fixed size, it will be said that it is float comma float. So always look at the documentation of what is expected by the function. That's it.
Okay, sir. Thank you, sir.
So I'm almost out of time. So I think I will now just wind up this lecture. As before, it will be recorded and uploaded on YouTube. And I will post the link for tomorrow's webinar very soon, maybe probably in a few hours. So thank you so much for coming and see you tomorrow.
Yeah, thank you.
Yeah, thanks.
Thank you.
Thank you, sir.